just send a chat, and then we'll just make it interactive from that particular angle. We are going to be starting the training as soon as possible. Yeah, good morning to you too. I can see some good mornings on the chat. It's wonderful to have you around. It's a privilege. We feel so honored. We feel so honored to have you around. So we'll go quickly to the business of the day as we have a lot to cover. The title of this course for today is how to know which subset of prospective customers to target for business success. That is what we are here to find out. Let's start like this. Let's actually introduce ourselves. Why are we here? What do we want to do? What's the problem that we want to solve in the next 3 hours or less than 3 hours that we have left? What exactly is the problem that we want to solve? The idea is that before we can start thinking of data science, data analytics, or whatever, we need data, and that's the historical data, and that's what we have right here. So assuming this is the data that we need, I will be using my mouse a lot to pass some information across and give us direction. Assuming this is the data that we are interested in, both the training, validation, testing, and everything, they belong to the historical data. So let's assume that you have been storing some information about previous customers, people that have done business with you in the past. And based on that, you happen to know some information about them, their age, their sex, and other details. And those particular customers, you happen to know whether maybe they've done something with you, they've been able to purchase a good with you, or they've been able to make some transactions with you. You've been successful as regards those previous customers, as in the success I mean now is that they have been able to do business with you. So that means that you now have historical data that contains some information about your customers, and that particular information is labeled in the sense that you know whether they will buy or they will not buy, whether they will do business or they will take the service or they will not take the service. So that's what we mean by labeled. So let's assume that we have all this historical data. So this historical data, from the machine learning perspective, which we are still going to be talking a little bit more about later, what we do is that we don't use the old data. We partition the data, maybe some percentage of it goes to the training for us to develop our model. And then from there, we can now start predicting on a new data set that doesn't have a label, meaning that on that new data set, we don't know whether that person will purchase or do service with us or not. So now, we can have this partition in 3 areas, maybe training, validation, or testing. But particularly, we can have it in 2, maybe training and validation. Some algorithms can take just 2. Some algorithms, depending on the data, you might want to stratify it and so on and so forth. But let's not get into that yet. So basically, what we are just saying is that for KNN, anyway, that's the algorithm that we are using. It's better to have it partitioned into 3. So we'll talk about this later. But what I just want to bring to us now is, for us to understand right now, is that if we have this old historical data, training plus validation and everything, we can develop a model for training data, and then whatever we get from this, the model that we get, after we have evaluated it, and the percentage accuracy is okay, is satisfiable, then we can use it to predict on a new data set that doesn't have label. So we predict those customers. So the idea now is that you now have fresh customers. Maybe you now have you have been able to get a data that contains likely customers, about 1,000 of them. So based on the model that you develop from this training data, you now want to use it to predict what will happen to these new customers. Are they going to do business with you, or they are not going to do business with you? That is the stage that my mouse is in right now. So after that, our goal in this course now is that now we know whether out of this 1,000 that we are prospecting, Now we know whether they are going to do business with us. Out of all these 1,000 customers that we are prospecting, now we know which ones are going to do business with us or not. So let's assume that out of those 1,000, we have about 500 that the algorithm has predicted that is to do business with us. And we want to target, we want to make a move on these 500, but there are too many. So we don't want to waste resources targeting some of them that maybe their probability of doing business is low. We want to go for, maybe we have resources just to target 10, and we want those 10 to be the best ones, the ones that have the highest probability that they will do business with us. Hence, out of those ones that it has predicted that we are going to be doing business with, you now want a subset, okay, which is that 10 out of the 500 that will do business with us. So that is this stage now. So the idea now is that after we have predicted for these new customers, let's now see how we can rank them so that those ones that have the highest probability of doing business with us, that is the subset that we are targeting. Those are the ones that we go for. And that is what we want to do in the next less than 3 hours. And I believe that we will have speed. So quickly, we are going to go into how this can be achieved. Please, like I said, if you are just coming, you can send us chats so that we can, if you are too fast, you need a clarification, we can do that. And please, just like we said in the introduction, it's purely practical. The training is purely practical. So the best way to get the best out of this training is to install whatever software that we are going to be using. Like for this course now, we're going to be using the Rapid Miner. So install it already. As I'm taking the training, I'll make sure that I'm slow so that we can be doing it as I'm doing it. But if, for example, you've not been able to install the Rapid Miner, don't be discouraged. You can just follow and understand. After the training, the video for the training will be on YouTube, and then you can subscribe, or we can even send you the link to the training, to the video, so that you can now download it and actually be able to use it on your own. But like any science-based course, data science is practical-based, and most times you have to do a lot of practice before you can be a professional. So we're going to go straight to the business of the day. We are going to be having just a quick information. We're going to be having like a 5 minutes break around 11:30 so that we can relax a bit and then we can continue again. So quickly, what we're going to be covering, we introduce ourselves to business analytics. That will help us lay a good foundation for what exactly we want to do. Then we'll look at predictive analytics. We'll zero in on predictive analytics. Then we'll look at the KNN algorithm. So up until that stage, we are just going to be talking about some theories because we need to lay a foundation. If I just take you straight to the Rapid Miner and start dragging and dropping, you might not know the reasons why we are doing some things. And so if you want to do it on your own, you might not be able to do a good job and achieve whatever it is that you want to achieve. So we have so after the introduction to the KNN algorithm, then we can now go to the practical side, a Rapid Miner, and pick a practical example and run through it till the end and achieve that goal that we were out to achieve. That's in the beginning that I just finished describing. After that, we have a little exercise that you can use to practice if we have time. If not, the data is already sent to you. That's the personal loan acceptance data. So you can just, based on whatever we did, you can practice it on your own, particularly because of data. Maybe some of us might want to save our data and all that, but we have sent the data to you so you can easily download the video and practice it on your own. Like we said, practice makes perfect. So that's quickly what we are going to be covering for this in this morning. Like I said, the materials that you're going to need, of course, the Rapid Miner installed already, I believe, then the data that we sent to you earlier, and then the video will be uploaded. So let's go straight to business. Introduction to business analytics. We are talking about knowing subset of customers. We are talking about making our business successful. We are talking about, maximizing the resources we have to get the best, clients possible. Now, one thing I should also say is that even if you are not particularly interested in business application, maybe you might be applying it to biology, you might be applying it to finance, you might be applying it to stocks, other things that are not business related. Thankfully, data science techniques, they are the same, whichever area of application. It's just the way of application that might be different, but they are all the same. So if you're not interested in the business application aspect, the fundamentals of the KNN algorithm, if you know it through this training, you can easily, be able to apply it for in other situations and achieve your aim. So, but for this training, we are focusing mainly on business and business analytics application. So when we talk about business analytics, what exactly are we talking about? We are just simply saying that we are looking for how to apply data science techniques for solving business problems. And that cannot be in isolation. So because of that, we are going to be looking at the process that it actually takes. Even though in this training, we might not be following all this process, we'll just zero down to the prescriptive analytics, but it's good for us to have an holistic view to what exactly is happening, okay, in the business world. You don't just, data science is beyond, before you can use inferences made from data science in business and use it to make more money or solve a lot of problems, it goes beyond just manipulating numbers. You have to understand some things about the business processes, and that's what I just quickly want to go through in the next few minutes. So we have what we call the information action value chain. What exactly is this? This is the process that a business data scientist goes through to be able to achieve maximum success. So we have, first of all, we have real world events. And for these real world events, simply what we are just saying is that when you are doing your data science, or you have a problem area that you are applying it to, it doesn't just happen, in isolation. So you have the business world. There are some characteristics of the business world that you need to be able to understand, and that's where the domain knowledge actually comes in. So as a data scientist, you need to have some idea about the domain of the business that you want to apply it to. Then there are some characteristics in that domain that you probably want to capture as your data that can help you to solve some of these problems. Then the next thing is capturing these characteristics. So you need to decide what technique you want to use to capture the data, and if the data is existing before, how do you bring them from different locations together for the purpose of data analytics? So those are the things that you might want to find out more information about as a data scientist. Then the next thing is, now that you have your data put together from different locations, you want to now go into preparing the data for analysis, that's extracting data for analysis. Before I leave this stage, it's very important for me to let you know that data analytics in the business world might not be the same as in the research world, because in the business world, your investors or whoever has given you the assignment is interested in the return on investment. And so whatever analytics you are doing, you have to always be benchmarking it with that return on investment. Having said that, the fourth stage is preparing your data for analysis. That's data extraction for analysis. Okay, so for data extraction for analysis, at that stage, what are you going to be doing there? Sometimes the data you might be lucky, you have a large volume of historical data, maybe over 1 million. And some algorithms might not do well, with even large volume. Some do well with large volume, some don't. So based on whatever technique that is suitable, you might want to do some sampling. Then, like I said, pulling together external and internal data. Now you have your data where you want it. You need to explore the data and pre-process it. So some of the things that I'm saying here, we're going to be doing it when we get to the practical section. Some we are not. So what that means is that it's not in all times that you have to rigidly follow this step. You use those steps as required. So the next thing that we have here is that You explore the data, clean it, and preprocess it. When you explore the data, what exactly are you looking for? You are looking for missing values. There are some algorithms that if you have missing values, it will create instability. Then you are looking for outliers. Yes, like for example, the KNN that we are going to do today is based on Euclidean distance, and Euclidean distance cannot is not stable. It doesn't do well with outliers. So you might want to explore the data and remove outliers. I will explain what outliers is later. Then you might want to normalize and then change some variables, maybe from categorical to dummies, depending on the requirements of the algorithm. Okay, so still on extraction for analysis, we have visualization. So there are several reasons why you might want to visualize. You can also visualize even for outliers. Then you can determine maybe the category of your data is not properly categorized yet. You might want to use visualization to take care of that. Then you might also want to visualize even to reduce some of the attributes that you are using, because if the attributes are too much, you might have some models might not do very well. Then that brings us to data reduction. So that's it. So what we are saying is that there are also some techniques that you can use to reduce the attributes that you are going to be using for your data analysis. Then we come to partitioning. Just like I said earlier when I was introducing the problem to you, in machine learning, if you have a set of historical data, you don't want to use everything to develop your model. So you divide it into training and testing. So you use the training a percentage of it is for training. Then after the model is developed, evaluated, and you feel good with the model, that's the evaluation results, you can go ahead with your analysis. So sometimes you might even need to transform variables. Maybe when the data was collected in real life, they just said amount spent, and that's not good for your analysis. So you might want to say, let's change amount spent to greater than 1 million, less than 1 million, and it has just two categories. So those are things that you might want to do. And for this training, I've said a lot for this data extraction, but what we are just going to be doing is, for this particular problem that we want to solve, anyone that is necessary out of this extraction, we'll pick it and we use. And then later, when we are taking care of other algorithms, we can be able to say, okay, this is the one that it needs, and then we use that one. So basically, that is the story behind the data extraction for analysis. So we continue, after you have extracted your data, we continue in our journey of information, action, value chain. After you have extracted your data, the next thing is to now perform the analysis. And to perform this analysis in business analytics, that's data science for business, we have three major types of analytics. We have the descriptive analytics, we have the predictive analytics, and we have the prescriptive analytics. So for the descriptive analytics, the goal there basically is that you want to be able to see how to describe what things look like now, and then what happened in the past. So whatever things look like now and whatever happened in the past, you want to use that to make informed decision about how to make your business succeed. So some of the algorithms that you use in this descriptive analytics might even be your simple statistical, calculations, then distribution plots, like all these, your histogram charts and all that. Then you might even want to go as far as association or cluster tree-based algorithms, neural networks, and so on and so on, and KNN, which is what we are using today. Then for the final one, which is the prescriptive analytics. So for the prescriptive analytics, you want to be able to go beyond predicting, and you want to link your analysis with decision making, okay, and recommend what exactly to do. And for this, most of the prescriptive analytics, most of the algorithms that is being used, they are optimization based and numerical optimization based techniques for business rules, financial models, and all that. So we also have courses for that. But For today, we are going to be looking at predictive analytics, and the algorithm that we are interested in is KNN. So after that, when you are through with your analysis, you want to summarize and present your results. Just like it's often said, a data scientist needs to know how to communicate the results. So at this stage, you want to summarize and communicate your results, interpret it so that managers, whoever is in the level of decision making, can be able to make decisions. So please don't forget, if I'm too fast, if you have a comment, you can send it through the chat. Next, you develop strategy. Now you have interpreted these results. The next thing that you want to do is you want to develop strategy based on whatever results that has been interpreted. And the next thing is you deliver whatever you have. So what we are saying is, at that stage of developing a strategy, that's where the return on investment is factored in. You have interpreted the results. This result that you have interpreted, how can it actually help the organization to plan and develop strategy to be able to achieve a high return on their investment? All right, so after that, now you are ready to deliver the pitch to whoever gave you the assignment, and of course presentation skills is very apt at this stage. Finally, we have you take action. If you don't take action, whatever you have done or discovered will not yield any results. And that's where that is the journey for a business analytics person. So anybody that is into business analytics, you must successfully go through all this in detail. So now let's go over to predictive analytics. Just like I said, that's where we are going to be zeroing down our training on. So for predictive analytics, we said it's for us to be able to understand predictive analytics, let's talk about supervised learning and unsupervised learning. Basically, KNN, that's K nearest neighbor. That's the algorithm that we are going to be going to our RapidMiner to go and implement and see how it works and all that. But it's very, very important that we lay a good foundation so that we know what exactly is going on. And that is a difference between a data scientist and any other profession. A data scientist, you have to be able it's science. So you have to be able to think about several ways to make things work better and more efficient. So like, for example, the problem that we have today is not only k-nearest neighbor algorithm that can do the prediction. We have other prediction algorithms that we like I mentioned, neural network can do prediction, logistic regression, multiple linear regression, and so many of them, even the Bayes, can do prediction. So usually as a data scientist, even though we have picked one for explanation purpose today so that it will not be too complicated for us, for some of us that is starting, as a data scientist, you might even want to try like 4 different algorithms, prediction algorithms that can, help you to solve your problem, and then you pick the one that has the highest accuracy, and then, you keep trying until you get the best accuracy that is possible. So let's look at k-nearest neighbor. Just like you can see the reference on this slide, this lecture or this course or material that we're using to present, it has been properly referenced, and you can see some of the textbooks that for more reading, more information. As a data scientist, the truth is that you have to read. You have to read. There's just no way around it. So we have furnished the material with quite a number of textbooks that you can easily reference for more information and for deeper understanding. So KNN. The idea behind KNN, it can be used for categorical prediction or numerical prediction. Let me just explain that. If we are trying to predict the future, we are trying to predict an intention of what somebody will do and so on and so forth, we are predicting something. That's predictive analytics. We might want to predict a categorical outcome. When I say categorical outcome, what I mean is that whether it's true or false, okay? Whether it's average, below average, or failure. Those are categories. or you might want to predict a numerical outcome, maybe stock value, the price of products. Those are numerical values. So each of these categories have different application scenarios. They have different algorithms that is suitable for them. But like we said, our goal is to determine the subset of customers that will do business. So that means that we are in the categorical outcome situation. When we now know the category that you fall in, we can now use whatever probability or propensity that gave us that category to rank you and get those ones that will be the most likely or highest probability of doing business. So the KNN algorithm can be used for both categorical and numerical. So to classify or predict a new record, what actually happens is that in the training data that I've explained earlier, the algorithm will look for the neighbors of a particular new, transaction that you want to predict for. When it gets the neighbors, it now takes a vote. Maybe it has one neighbor. That means there's no need to vote. Whatever category that neighbor belongs to, that's the category that it will belong to. But if it has like 3 or 4 neighbors, you can now find out which one has the highest votes out of those categories that we are trying to predict in the neighbors. So maybe we have 4 neighbors. 3 of them belong to one category, 1 of them belongs to one category. So the category that has the highest vote, which is 3, will be where we are going to predict that this new record will belong to. So that's just a simple story behind the KNN algorithm. So, and what I just explained is what we have here. So, and let's look at a more graphic illustration. Before we get to the graphical illustration, this is also attempting to explain to us that, remember, we are talking about k-nearest neighbor algorithm. We said it predicts based on the neighbors. So the question is, how do we now, measure distances of this new transaction that we want to predict? How do we measure how close these neighbors are to it? Okay, we have several distance measures that we can use. And then the one that is popularly used is the Euclidean distance. And this is how we can calculate it. So if, for example, we have 2 records, and one of the records has 3 attributes, x1, x2, and xp, for example. And then the second record too also has 3 attributes, u1, u2, and up. So this formula can help us to get the distance between these 2 records. And that is what k-nearest neighbor will be using. There are other distance measures. When we get to the RapidMiner, you will understand it better. There are other distance measures that we have in the RapidMiner. Like I said, as a data scientist, you try all these distance measures and you see the one that gives you the best results. Okay, so let's proceed. And before I proceed also, I should also say something that is very important. Since k-nearest neighbor uses distances, then it is very important that we don't allow one attribute to have an undue advantage over the other one. And that's why we normalize all the attributes of that particular transaction whenever we are using nearest neighbor. For example, if you have an attribute that stores salary and somebody's salary is going to millions, and we have another attribute that stores age. Age only stops at 100. You might not even have somebody that is 100 years old that is still working. So in that situation, you want to have a common ground for those 2 attributes. You don't want one, that's the salary, to have undue advantage over the other one. And that's when you start talking about normalization. So normalization helps you to rescale the attributes and bring all of them to a level playing ground. So if you are still with me, I want to congratulate you. We are moving on gradually. We are almost getting to the practical, which will be more interactive and then of less theory. But these foundations are very, very important. Data science, data analytics is beyond dragging and dropping. It's beyond computing numbers. you have to actually understand the reasons why you need to make some decisions to give you an optimal result. And that's why we cannot gloss over this step. Please, if there's anything you don't understand, send me a chat and I would respond. Okay, so now the idea now, yes, we have a more graphical illustration here. I will use my mouse to be able to show us some explanations. So now let's assume, for example, that this is our training data that we have plotted. And this training data has just two dimensions. We have the lot size and we have the income. So assuming we plot it on this plane, okay? These points, we can see this 18, for example. Since the class is not too rowdy, I think I can still take one or two responses so that I'll be sure that people are not sleeping. So since we have, okay, let's look at the data. Let's look at this plot. We have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So assuming we have the total number of data that we have is 24 and we have divided it to training and testing. So we have maybe 60% for training, 40% for testing. And this is the training data that has been plotted here. Let's look at this X. Let's assume that this X is the new transaction that we want to predict. We want to know whether this particular X will belong to the category of owner or non-owner, okay? Before we even come to this, I think it would be nice for us to actually see what exactly this data looks like in an Excel format. So I'll quickly go there and come back. Okay, so this is what this data actually looks like in an Excel format. We have only two attributes, income and lot size. And then this is the category. This is the label that I was talking about when I was in the beginning. So this data, okay, what is it about? It's about maybe home owners. So we know the income of these home owners, we know the lot size, that's where their property is sitting upon. And then we now want to know whether they are likely to purchase or they are not likely to purchase a particular riding mower. So that means that this is now the target attributes now. So let's assume that we have been able to divide this into a training data, and that is what we plotted on this particular output. So we have this X, and we want to determine the category that this X will belong to. Now, K nearest neighbor, just like I explained, what it does is that it will look for, using distance measure, the Euclidean distance, it will look for which of these points is closest to X that we are looking at here. So if I look at this now, I probably want to say 14 is close to X, 9 is close to X, 1 is close to X. If I'm looking at 4, I might add this 20 here. But if I'm looking at 3, for example, I might say 14, 9, and 1. So if I'm looking at 3, and it's always good to pick maybe odd numbers so that it will be easy to break the tie. So now I'm looking at 3, 14, 9, and 1. So out of these 3, this is an owner, this is an owner, making 2. This is a non-owner. So if I'm going to predict for X, what will be the category of X? That means that X we have, let me take response. Who wants to be brave enough to answer? Can anybody try? Okay, yes, I can see chat. Okay, can you explain more about normalization and owner? Oh, okay. So I will just go through that briefly. I have a chat that says I should explain more about normalization and owner. So I will do that and I will come back to asking the question. So the idea behind normalization is that if you have attributes in your data, some of these attributes might want to take undue advantage over the other, in the sense that if one of the attributes is income or land mass, and is running into millions. So all the points in that attributes, there are 1,002,000, 1,050,000, and so on and so forth. And you have another attribute that is just age. Now that age now, it can only take values from highest 1 to 10. So that means that if you use it to calculate the Euclidean distance, which is the distance between this and this and this, it might one might swallow up the other. So that's why you need to bring all of them to a level playing ground by applying normalization. And we'll see how we do it in rapid minor just in a minute. So that's about normalization. Now for the owner and non-owner, that's why I went to show you the data, that we have a particular data that is storing information about maybe people that have houses, and the idea of it is that we want to know some information about them, maybe their lot size, their income, and then we now want to know whether they have a mower or they don't have a mower. So that's what we want to predict. So the idea now is that if I have another person that has an home, if I know his lot size and I know his income, I want to predict whether will he own a mower or will he not own a mower. So that is the classification part there. That is the label. That's what we want to predict. Own a mower, don't own a mower. So we are now saying that let's just take, we can have several attributes. It's more than these two. The exercise that I will give you will have attributes that is more than income and lot size. But let's just say we have only income and lot size so that the thing can be easy to explain. And we plot it, for example, so that we can be able to appreciate the distance measure that we talked about in this KNN. So if we have the distance measure and we want to use it to calculate the distance between this new guy, see this is X, where it's not plotted, it doesn't have a value because we don't know whether it's going to be an owner or a non-owner. But we know that it has, X has a lot, an income of 60 and it has a lot size of 20. That is X. But is he an owner or is he a non-owner? We don't know. So that's what we want to predict using this KNN. So we are saying that what KNN does is that it will look for, when it plots it, when it plots all those points, all those transactions based on the attribute values, it will look something like this. So it will now look at this one that I want to predict and say, okay, those ones close to these guys that I want to predict, how many of them, odd numbers? You can pick the highest, that's the value of K now. So we'll get to how we determine the value of K later. But the idea now is that I want to see out of these 3 that we have selected, okay, how many of them is owner, how many of them is non-owner. So we can see that the 3 closest to X, which is where I'm hovering my mouse around right now, 2 of them is owner, 1 of them is non-owner. So that means that we are going to categorize this particular guy as a owner because the vote says give it to owner. That's if we pick our K is equals to 3. If we pick K is equals to 4, for example, we can see that there is a tie. So that's why we usually want to pick K that is odd number. And then what determines K, we'll talk about that later. So that's how the classification is done using the K nearest neighbor. Because when we get to rapid minor now, all we are just going to be telling ourselves is, okay, pick this one, pick a value for K. The question is, what is K? You might not know that. That's what I'm trying to explain. So K now is the number of neighbors that you have decided to zero down on to make your classification. All right, let's proceed. So what are the business applications or application scenarios of this this KNN algorithm? So the business application or application scenarios of KNN algorithm can be used to classify loan applications to, for example, is this loan application risky or not? And then when you now predict those ones that are risky, you can even now rank them and say, how risky are we talking about in this situation? Then we can use it to predict fraud. We can use it to, maybe you want to market your electronics or products, some things, services and things like that. For example, the one that we are talking about today, we can use it to predict whether this will be a good customer or this will not be a good customer, and so on and so forth. So let's talk about, we are done with explaining what the KNN algorithm looks like. The next thing that I want to look at is data preprocessing for KNN algorithm. I talked about data preparation the other time. Now let's zero it down to KNN and now see what exactly are the steps that we take when we are preprocessing for this KNN algorithm. Our goal when we are preprocessing for KNN is that we want to reduce the dimension. Why? Because we can see that KNN uses distance measure. And if the attributes that you are going to, for only two, you can see that we're able to represent two attributes, lot size and income. We're able to represent it on a two-dimensional plane. Imagine when you have attributes like 20, it will be looking too complicated and it will go to exponential. So you don't want to use too much dimensions, and you also want to make sure that the dimension that you are using will be the most important dimension. So I have a chart here, so I'm going to slow down a bit and pick the chart, the reaction. Can you explain more? Okay, I think I've done that. Please, Ma, did you say plus are non-owners while zero are owners? Yes, that is exactly what I said. That's using the, yes. Yes, so these are the owners where my mouse is, and these are the non-owners plotted using the data. We are going to see how we are going to plot this actually when we get to the rapid miner, and then we'll see what exactly is happening. So yes, you are correct. Plus are the non-owners and zero are the owners. So we are going to see it. So back to data preprocessing for KNN. So I said the goal is to reduce the dimension. We don't want there to be too many dimensions, too many attributes. And at the same time, we want the attributes to be the most important attributes that we are going to be using. That's one. So, and then we also know that Euclidean distances, they are sensitive to outliers. So one of the goals for our data preprocessing is to look for outliers and deal with them so that they don't affect our model. So most of the times when they say, oh, I'm doing visualization, you need to know what exactly is the goal when you are doing the visualization or the preprocessing, so that you'll be able to know when you have achieved it. So I have another chart here. I'm going to pick it up and use that to slow down a bit. How many attributes are okay for KNN? Yes, so somebody is asking how many attributes are okay for KNN. Like we said, the more the attributes, the more exponential the calculation, and the more complicated. So we are saying that we need to reduce the attributes. So exactly how many attributes is best will be determined by the data that you have. If, for example, you have just 10 attributes and you have done your attribute reduction and you ended up with 5, that means that would be the best. But when you say ended up, you evaluate and then you see whether your results, the accuracy is okay. Then you can say, let me use this 5. So, and that's another thing about data science. Nobody will be able to give you numbers and say, for KNN, just use 10 attributes. No. You have, as a data scientist, you have to be able to make those decisions based on your evaluation results. You evaluate. For example, if you use 2 attributes, you know it's too small. Even if without evaluation, you will know that is too small. So you want to be able to evaluate, get your result, the result of the evaluation, and say, okay, I'm comfortable with this, and then I can proceed. And then, depending on this available data that you have, that's the available attributes that is captured in your data. So, but if, for example, you have up to like 100, you might just attributes, you might want to reduce it at least to maybe like less than 20 that will make your prediction stable. Okay, so that's by way for as answer to that question. So take care of outliers. because of this distance measure that KNN uses. One of them is Euclidean distance, most popular one, and is sensitive to outliers. So that's for data preprocessing. So those are the goals. There's some other things that you might want to take care of for KNN, but let's just stay with this. Those are the most important ones. So for this KNN, the data preprocessing, it's the first thing that you might want to do when you have your data is to visualize. So when you visualize the data, you might use bar charts, color charts, side-by-side box plots, and box plots. And each one of these charts have conclusions that you might want to make from them. Let's take an example. Since we are going to practical, I will still be saying more about that when we get there. Let's take example of side-by-side box plot, for example. Okay, the outcome, if you plot all your attributes on your side-by-side numerical attributes, predictors, on a side-by-side box plot, depending on how separable they are, that's what will determine which one is a good attribute that you might want to pick out of all those attributes. So you use this visualization to decide which attributes moves to the next level. So when we get to the practical, we'll talk more about it. I can see that somebody is just joining us. You might not be able to repeat, and in case you are not following, just be patient, listen, see whichever you can understand. We are uploading the video immediately after the training, so you can be able to catch up with whatever you missed. The next thing after the data visualization in data preprocessing is normalization. Okay, so it's for KNN algorithms, it's very important to normalize. We are going to normalize, and then we will see it, and then today, and then we'll be able to understand it better. Then for KNN, another thing that is important here is that categorical variables must be converted to binary variables, that's dummy variables. So dummy variables are variables that consist of only zeros and one. And what it means is that, let me just say one or two things about the dummy. So the idea is that if I have a category like owner and non-owner, if I want to convert it to categorical variable, dummy variables, I might end up having owner, under the owner, I might have, for a particular transaction, if it's an owner, I will have 1. Okay, if it's not an owner, I will have 0. So that's categorical variable. We'll see a practical example, so we can just relax. Then the third thing that I want to do for the data preprocessing for KNN is the data partitioning. Okay, we want to partition the data, maybe 30%. And for KNN, actually, it's advisable, unlike most machine learning algorithms, that you partition data into 3. That's what I showed you earlier. You have your training. You can now decide the percentage that will be. You have your training, you have your validation, and you have your testing. So you can make the training maybe 60%, validation 30%, and testing 10%. So what are the usefulness of these partitions? The training one will help you to develop the model. And then the validation one will help you to evaluate that model that you have developed for different values of K. Remember what we call K. K is the number of neighbors that you want to use for your prediction. So you can use 3 neighbors, 4 neighbors, 5 neighbors, and so on and so forth. And then check the accuracy. So the one that has the highest accuracy, is the K that you're going to select. Then the last one, which is the testing partition now, you now use to evaluate using that best K that you have selected. Well, we are using RapidMiner, so you probably have to keep running the KNN for 3 neighbors, 5 neighbors, and so on and so forth. But if it's R, for example, we can just, we have codes, we have our steps that we can do, that we can just load all those different types of K, and it will tell, and it will calculate the accuracy, and it will tell us which one is the best. But this is RapidMiner, and we can be able to use it all the same and still maximize, whatever we have in it there to be able to get our best value for K. So after the partitioning, the next thing is evaluation. And that's where we are going to be tidying up the theory for the course before we go to the practical. And we are in a very good place. So we have maybe we have just used about an hour. So we can't conclude that any model is good for prediction if we do not evaluate. And for prediction, I said there are two different types of prediction, categorical and numerical. And since we are particular about categorical outcome, I'm just going to talk about how to evaluate categorical outcome. So usually we evaluate categorical outcome using true positive. What is true positive? Okay, true positives, they are the ones that were supposed to be positive and they were correctly classified as positive. So if we have two classes that we are trying to predict, okay, it's supposed to be an owner and it was correctly predicted as an owner, so that's true positive. Then true negative is supposed to be a non-owner and it was correctly predicted as a non-owner, that is good. Then we have false positives, okay? So negative tuples that were incorrectly labeled, and then false negative, positive tuples that were mislabeled. So the last two, they are the ones that you want to reduce as much as possible. Let's look at what this looks like in our confusion matrix. That one will make it easier to understand. So we usually capture those four things in form of a confusion matrix. The idea behind this is that you can see the true positive and the true negative here. This and this is where you have the correct answers. And this, the diagonal, this and this is where you want to have as much values as possible in your evaluation. So this and this one and this one has to be reduced as much as possible. And that's where you get your percentage accuracy. So if, for example, the whole of the transaction was 100 data points or 100 transactions, and you now have maybe 50 here, 40 here, that is 50 plus 40 over the total, that would be 90 over 100, so that's 90%. So that's a very good accuracy. But if you have 50 here and you have 30 here, and then these ones, the total of them is just 20. So that means that false negative and false positive, if you add them together, you're going to be having like 80%. So that means that your accuracy is very low, because 100 minus 80 will give you 20%. So you have only 20% in the true positive and true negative. That is not good for your model. So that is the simple way to explain. There are other evaluations, but this is the most important one that we want to talk about for categorical outcome. All right, so like I said, there are references on the slide. You can easily pick up the textbook at the back just to be able to get more information. All right, now, like I said, we're in a very good place. Before I go to the practicals, I'd like to take few questions if there are, or I would like to ask that should we go on our break now and come back for the practical, or we can continue, whichever. So can I have some response? Yeah, somebody said, please be kind to record the meeting. Okay, no problem. Definitely, I'm going to send it to I'll get across to us. Yes, okay. Should I continue? Let me have your response. Or can we do our break now? 5 minutes break. Okay, okay, okay. Okay, somebody said we should continue. Somebody said, okay, break. So let's just do, since we have a lot of things to do today, like somebody said, we can just do, let's have break. So I have like 2 let's have break. Okay. Okay, so let's just do 5 minutes. 5 minutes, and then we'll come back for the practical. We have seen the theory. The best way to enjoy the course or the training is to see the practical. All the theories that we have been seeing, let's see what it will look like in the practical. So we'll just take 5 minutes. We'll be back. I will continue exactly by 11 15, 11:15. Welcome everybody. This training is powered by INF Network Solution. Our vision is to improve business profits through business diagnosis solution. We also offer training both individual and corporate. These are some of the facilitators of the training. You can get more information about them on LinkedIn. Cost structure. Descriptive analytics 1. For now, we have 2 topics under that particular module. Network analytics 1. We also have 2 topics under that module. We plan to introduce more. Predictive analytics 1. We have about 5 topics under that module currently, and there is more to come. We have more courses that we are going to be introducing. We have the prescriptive analytics, and then we also have the text analytics and many more. For more information and updated course content, you can check out our website, datascienceniger.com/webinar. Certificates. Though not compulsory, you can get certificates for the courses or topics that you have taken, and there's no cost attached for the certificate provided you have attended the training, whether it was free or you paid for it. We have a ways of taking attendance so that we can be sure that you actually took the training. And of course, certificates are awarded based on the category of topics that you took, just as explained earlier. So we have, if for example, we want to take a certificate for Predictive Analytics 1, we have about 5 topics there. You make sure that you have attended all those 5 topics, then you apply to take the certificate. We pick a day for you, and then you take the assessment for all those 5 topics. That's in a day, and then we can award you the certificate. Current topics. How to know which subset of prospective customers to target for business success. That's on the 18th of July 2020. It's free. We'll be using KNN algorithm and the Rapid Miner platform for the practical. July 25th, 2020. How to build a successful data science for business career. It's also free. It will introduce you to the career paths or research, business, or consulting in data science for business. 1st of August 2020, we have a free training on people analytics using network analysis, and the practical will be done using Gephi software. For more information, check out our website. We have a training August 15 and August 16, how to use descriptive analytics to improve your business profit. It's 3,000 Naira, very cheap. You can check out more information on our website. It's going to feature a lot of descriptive analytics too. We have bubble plots, box plots, maps, and so many more. Preparation for training. To prepare adequately for our trainings, we'll be sending you a mail 3 days before the training that contains 3 major things. The first one is the link to the platform to join the training. It could be Zoom, it could be Google Meet, or Microsoft Teams. Then the second one is the link to the video that contains the installation steps for the software that we're going to be using for the training. So it is advisable that you follow this video, download the software, and install it before the training so that you can be able to flow in the training. Then the third one is the link to the data that we have for the training. So you download the data and get ready for the practical sections in the training. Okay, so we are back and we want to resume so that we can cover a lot in the time that we have. So I'm going straight to the rapid minor. So I'm going straight to the rapid minor, and I believe that if you were able to install rapid minor before the course, by the time you were through, let me take feedbacks. How many people were able to install the rapid minor? Please, can you send me a chat? Okay, somebody said I should send the materials, and how do we get links for other classes? Of course, it will be sent to you. The links for the free trainings that we have one same time on Friday or on Saturday next week. That's how to be a successful data scientist. That's we'll send the link to you definitely 3 days before. So we always, at least for the free trainings, we always send the links ahead. And even for the one that is not free, if you pay, we send it to you. So then I want to, okay. Okay, thank you. Okay, I got only one only one person installed the rapid minor. Ha. The best way to enjoy this training is for you to be doing the practical. Though it's not yet late, you can still use the uploaded video to be able to practice. Okay, I was. Okay. Thank God. So we had some few I was. Okay, thank you. So we go straight to the practical. This is the rapid minor environment for the people that are just new into rapid minor. Yes, the Telegram group. How do we join? When we were asking you to register for the training or for the club, we asked you to drop your number. So if you dropped your number, we'll create a group before the end of this coming week. And then if you did not, we will still get across to you by email, or you can send us an email of your Telegram name. So we will just add you. Okay, so for the practical, this is a rapid minor environment. If you are used to it already, you can just refresh your memory. But if you are not, I'll just try to introduce the sections that we have in this rapid minor. The first section here, where my mouse is right now, is called the repository. And that's where you get to import your data. And you can also import your data through your creator, but this is one way to import your data. And it's always very good to create, just like we're going to be doing in the next few seconds, to create, whenever you're working in rapid minor, create a repository. So I'm going to be slow in this practical a bit so that the people that have their rapid minor, they will be able to follow us, and then they keep doing it. And then even if you don't have your rapid minor, you'll be able to understand it. And by the time you want to do your practical, on your own, it will be easy for you. So it's always good if you have a project, create a repository and there are two things that you put. You put the data that you want to use, and you also put the process that you have created, so that even if you come back later, you can still find that process there and the data, and then you can still run it. These are some of the projects that I've created before that I can easily open and run, or I can create a new one. So this is where you do that. Now, this section is the operator section. So for this section, all the algorithms, all the methods that you might need to use, they are here, one way or the other. For example, if you look at under model, you will see predictive models. Okay, this is where I am. You can just see where my mouse is. This is where I am. You have under predictive models, you can have different types: neural network, logistic regression, trees, rules, support vector machines, discriminant analysis, ensembles, and so many. So, and then That's predictive. Under segmentation, okay, you have all these, so you have so many, you know, models here that you can bring, or even association, different types of association algorithms, and then so on and so on. And optimization, that's for prescriptive. Okay, you can see there's so many. Then time series analysis, forecasting, you have all of them there. So all you have to do, if you, the name, even if you don't know the name, you can go and check. So for example, I want to do correlation analysis. Now I know that correlation matrix is there. All I have to do here is just type correlation, and then it will bring out correlation matrix for me. So from here, whatever I need, I can drag and drop it here. And by the time it appears, I would start, you know, editing it and working on it and get whatever I need to do. So while we are waiting for that to be dragged and dropped, we have, okay, that's already come. Let me not pick another one. So the correlation metrics that I dragged and dropped is what we have here. So thankfully, I can use that opportunity to explain this environment. So this environment is where we design. It's called the design environment. So whatever algorithm we need to do, preprocessing or whatever, we can drag and drop it in this environment design, and then, you know, we can, once we run it using this button, okay, using this button, then we can get our results, which will be displayed on this tab. So yeah, so I didn't mean we had something that we ran, we will see the result right here. So this is the result, and this is the design. Okay, so another palette I would like to introduce to us before we go to start our work is this particular one. So if you have an operator here or a process here, okay, if you have an operator here, if you click on this process and you come to this side, you have two different palettes that you have. This is called parameters, and this is called this is the help. This one is the help. So for this parameter, this is where you make some settings. For example, if I want to do correlation metrics and I want the correlation metrics, I want to normalize the weight, that normalization that I talked about earlier, I can just, you know, click on this place, and it will make sure that normalization is performed on the data that I want to correlate. So, and this particular pane is the help, okay? This help, as a matter of fact, you can learn a lot about these operators using this help. So it will tell you the algorithm that was used. Maybe there are several algorithms to tell you which one was used. It will tell you how to select from the different algorithms. So it gives a description of this particular operator that we are going to be using, or that we have dragged and dropped on our design environment. So this help, you can see there's just so much there that one can go through. It will tell you how to set parameters for this particular operator so that you'll be able to get the best out of the operator. Okay, having said that, and having used that opportunity to familiarize ourselves with the environment of this rapid miner, let's go to the problem that we're out to solve. So for the problem that we're out to solve, we said that we want to look for the subset of customers that will most likely do business with us, and then will be successful when we make our pitch to them. I'm going to go back to the PowerPoint. Can we see my screen? Please just send me a chat if you can see it. I want to be sure that you can see. Can you see the PowerPoint screen? Particularly the predictive analytics example. Okay, thank God. So we can continue. So now this example that we want to use to solve this the problem intended is still the riding mower example that we have been using since. So let's assume that this is the data. We have about 24. The first the heading here, the first row, as it were, is the title. So if you remove the first row, we have about 24 data points here, and it's telling us information about some home owners. These homeowners, people that have a home in a particular place, we have been able to gather data about them. So these are historical data. It contains 24 points. And it has two attributes, and it has a label. That's for this 2 to 13, for example, we know that they own lawnmowers. For this 17 to 25, we know that that's 12 of them. We know that they don't own lawnmowers. So the idea now is that if we know a new record and we know its income side, in the income, and we know the lot size, we can predict whether he will have a lawnmower, or you want to buy a lawnmower, or you will not want to buy a lawnmower, because these are the ones that I've bought and these are their details. So because of this data that we have, we can train it and then develop a model that helps us to predict whether you will have a lawnmower or you will not have a lawn, or you will be interested in buying a lawnmower or not. Okay, so this is the example that we want to use for the practical. So the solution steps. The first thing is, in our RapidMiner, we need to load the data, preprocess it, just like I've explained, check the statistics, check whether there are missing values, visualize the data, perform attribute reduction, partition the data, develop the model, and evaluate the model. That's the first thing that we want to do. So when we are through with that now, we can now use it to predict on new data and then rank them. So let's quickly run through this one in RapidMiner. So I'm going to go over to RapidMiner. So in RapidMiner now, I'm going to delete this. We are starting a fresh analysis. Yes, I have a chart. Yes, we have another example. Okay, that's the loans application, but I need to use this one first to explain, because it's very simple. Then we'll now pick an example that is more complicated. So right now, RapidMiner, first of all, we are going to import the data. So before we import the data, you can create a repository. So I'm trying to create a repository. Let me name my repository online KNN. Okay. So now I have a repository. It's named online KNN. You can see where my mouse is now. I can add some folders, one to store data and one to store process. So if I want to come back, all my processes will be here. I don't need to recreate them again. And if I want to come back, all my data will be here. So now I have this repository. I have two folders. So the next thing I want to do is to load in my data. So in order to do that, I can click on import data and look for where the data is on my computer system. So my data is on the desktop. I can pick it from the desktop. So the training data, if you are doing it on your own, if you are doing it right there, the training data that we sent to you, training one data, you will see this riding mower Excel sheet there. So you can click on it. So this is the data. It has these two attributes. So the next thing that we want to do is that we want to just load in the data, and we can format it while we are loading it in. So if you have the rapid miner, if you downloaded the one that is currently on their website 9.6, you will see that this is how you format the data. So from here, this is the attributes. Now I can decide to change this. For example, if I don't want it as an integer because it's saying that is real, but by default it usually gives you the right attributes. So these are the places that you can change it. Okay, if for example you want this one to be numerical, you can change it here, but it has given you the default data types, which is okay. So you click on next, and then you select this folder inside your online KNN that I just created, and finish. So that loads in your data. Now the data is in rapid miner. So the Excel sheet I was showing you earlier is now in rapid miner. So I said the first thing that I said we wanted to do is that we want to explore the statistics. So you can click on this. So we can see that we have 3 attributes there: income, lot size, owner, and so on and so forth. So we have these are the statistics. It's telling you how many, what's the average. So you can use this to do quite a number of decisions, and then you can see that it's telling us that we don't have any missing value. If we have a missing value, there are ways to take care of it, which we might talk about later. Then for the visualization, which is the next thing that we want to do, just clicking on this tab will tell us how we can visualize the data. So this is visualizing the data using a scatter plot. If I want to visualize it using a box plot, for example, I can do something like this. Oh yes, somebody is saying slow down a bit. Please ma, how did you load the data into the repository? Can I slow down? Please slow down. So I've slowed down. Hallelujah. So I'm going to go over that again. I'm going to go over it again. So I'm going back to my design view. So go back to your, this is the result. So go back to your design view. You just click on this tab. Okay. So what I want to do is to repeat what I've done. Once you have created, somebody asked, how do you create the repository? So I'm already where you can create the repository. So if you click on this, you just follow the wizard. So if I click on this, it will ask me next, and then I give it my repository. I don't want to create another one. I created one earlier. Then you click on finish. And after that, when you click on finish, you will see the repository right here. So you can right click on it, and then you create the subfolders there, just like that. So you name it data and process. So we put the data that we load inside data, and we put the process that we load inside process. Okay. So now the next thing, when we have loaded our data, so if I have created the folder, this data, this is process, and I need to bring in my data, I can click on import and then look for wherever the data is. So my data is on the desktop. So I'll go to the desktop and look for the data. So the data will send to you, like I said, the riding mower, you can select it and then click on next. By the time you do that, it will appear right here. Okay. So if we have the data now in our repository, to do anything on it, which is what we want to do, we want to explore the statistics, we want to visualize the data. Those are the things that we want to do. And we even want to do correlation analysis on the data. Okay, so that's what we want to do now. So we can bring in the data from here. I'm trying to slow down. Okay, so you can see how I've clicked on my data. I'm dragging it to this point now. Okay, so now I have my data here. If you click on this and you click on parameters, for example, it has loaded whatever data that you put in your repository. So the next thing that we want to do, if I click on this, to be able to see the results, I can just click on this and run this. Oh, sorry. So you create your link to the output, and then you can run it. We want to see, we want it to bring in the data. Did we get that? Just send me a yes, please, so I'll know we are following. Did we get that? Okay, no. I have a no. So I'm going to repeat. I'm going to repeat it. I said you create a repository by clicking here. Then you import, after your repository is created, you will find it right here. So you can add some, if you don't add any folder, it's just, whatever you're bringing, it will just drop it into the repository like that. But it's always tidy to right click on the repository and create subfolder. Name one data, name one process. So for one, we store the data, for the other, we store the process. So now this is the data. I can now import data and put it inside this my data folder. So I look for wherever the data is. This is the third time I'm taking this. Then pick the data. We are using riding mowers, and then we click on next. And then we keep going, select the attributes and so on and so forth. So I brought it in before, I don't want to bring it in again. So now that your data is here, there are two ways to get your data into your design environment. Remember, it's data that we want to analyze. So you can decide to bring in your data from here and drag it here, or you can even use, we'll use the second approach when we are doing the second way of running the model. So for now, we just drag in our data from here to this place, and then we link this to the results. So while we are just running, we are not performing any analysis on the data. We just want to run the data and see the statistics and visualize it. That's just what we are doing. So by the time you drag your data from this point to this point, and then you create a link from this out to this place, and you run it, okay, then you get something like this. So now we have our data. If the attributes were plenty, you're going to see all of them displayed here, just like the second exercise that we have that I said we are going to look at. So by clicking on statistics, for example, you are able to see the missing data if there were any, so you know how to take care of that. That's for another course. But for this one, we don't have any missing values. Then you can see the minimum of these attributes, the maximum, the average, and so on and so forth. This is just for our information. Usually, the minimum can help us, or the average can help us to decide what value we will use for our missing data, if there was anything. So, but for now, the statistics looks good. Then we go to visualization. So if you click on that visualization, there are so many plots or charts that we can use to visualize. Yeah, somebody said he's getting something else, so we'll not be able to troubleshoot that now. So you just follow, and let me run through the video, let me run through the training, and then when it's done its course, you can try to repeat it when you download the video. So I'll just continue. So by clicking on this visualization, you have so many. If you click on this plots type, you will see so many plots that you can pick and use to visualize. So we are just going to be using the scattered plots. You can try so many depending on the conclusions you are looking at. But since we are looking towards prediction, we can actually use the recommended ones, scatter plots, color coded, just to be able to see what is happening and so on and so forth. Then we have we can try, so this is for scatter plots. So it's telling us that income is on the x-axis. You can see my mouse, and then it's telling us that lot size will be on the y-axis and so on and so forth. So and then we can color code it with ownership. Usually when you have two numerical variables, you can color code it with the outcome variable, which is probably a categorical variable. So that's what we have right here. So that's what we have here. You can see the data has been plotted for us. The blue ones belong to the owner, the green one belongs to the non-owner, and all the data is being plotted, two attributes. Then we can see, if we want to try the box plot, we can have something like this. So this tells us what are the conclusions that we can make from this. First of all, what is this? This is a box plot. What has it plotted? It has plotted the attribute lot size against the target variable, which is the ownership. So since it has two categories, owner and non-owner, all right, so it has given us the idea of the number of owner, that their lot size is between, that is 17 to almost 22 right there. So when you see a box plot like this, this means that this is the 25th percentile, this is the average. So the average of lot size for owner, okay, is like 22. Then this is the 75th percentile. So we'll talk about that later. But basically what we want to conclude by doing this box plot is that we just want to see how separated these attributes are. And so we can see that at least we have a variety in the owner and the non-owner. But from what we can see here, we can see that the average of non-owner lot size for non-owner is about 17.5, which is this line traced to this place. But the average of owner is about, for lot size, is about 20.5, thereabout. So that's visualizing it. So we might want to, if we have a lot of attributes, we just have two for this one. If we have a lot, from here we can plot those attributes beside each other and then decide which one is more separated, and then we can decide which ones to select for our analysis. So I'm going to move on. So I'm going to move on to the correlation analysis. So I'm just going to go back to my design. Okay. So in my design now, I already have my data here. To perform correlation metrics or correlation analysis, all I need to do is to bring this correlation matrix here. So please, if I've lost you, just be patient. By the time the class is over, you can repeat it again using the video, but I need to continue. So to perform correlation analysis, all I will do is just bring in the correlation matrix operator from this place by typing correlation. Okay, you see the correlation matrix, you drag it, just like we drag the riding mowers, you are dragging it to this point also. And then you have your operator there like that. So now the next thing that we want to do is, let's run our correlation matrix. Like I said, to set the parameters of these operators, just click on it and you can be able to see this place that my mouse is right now. So if you want to correlate all the attributes, by default, it has already put all for you, all the attributes. And if you want to correlate a subset, maybe not all of them, you can click subset and then select the attributes that you are interested in correlating. But for now, we can correlate all the attributes. There are just 3 of them. So I'm going to pick all. Notice, I'll just explain the ones that is important in these parameters. That's what I'm going to do for the other operators that we are going to be using. So notice this normalize. So that means that you don't just want to correlate the attributes like that. You want to make sure that it's normalized. So if you want to find out more information about the normalization function that is used, if you click on L, it will tell you the kind. So from here, you can read the kind of normalization function that is using. And I believe that that should be Z-score. Z-score. So if you take time to read it, you find the correlation, you find the normalization function that is using. So now this is the correlation matrix operator. If I run this, okay, so it's done running, so I can be able to see the output. Okay, so we are looking for the results. That's the output. Okay, notice that I was not able to get the output because I did not put a link. So one thing about this rapid miner is that whatever you want to see in your output, that's what will determine the lines that you have here, for example. So if I wanted to see the exact values, I could do this. Then if I want to see the correlation matrix, I needed to add that from the metric. This is MAT right here. So if you add it to RES, the second one, you'll be able to get the outputs that you are looking for. So now that I have added it, if I run it, okay, so now I have my correlation matrix. So what does this correlation matrix imply? Like we said, when we are doing prediction, we have what we call attribute reduction. We might want to remove some of the attributes because they might make our model unstable. For correlation metrics, the reason why we usually do it is I want to discover attributes that they are exhibiting multicollinearity. And that's simply put as the presence of 2 or more predictors sharing the same linear relationship with the outcome. So if that is the case, we want to remove one of them so that they will not make our model unstable. Now, when you see a correlation matrix like this, if I trace lots, if I want to know the correlation of lot size to the label, that's the output variable. So this is lot size. I can trace it to owners. That's whether it's an owner or not. You can see the correlation value between lot size and owners is minus 0.554. So that means that for this present correlation, so what it means is that there's a negative correlation between lot size and owner, which is okay for our analysis, because if the correlation is positive and it's high, maybe 0.9, for example, we might be thinking of thinking twice about the attribute that is too correlated to the target attribute. So that's basically what we just use correlation to do. I'm not going to waste too much time on that. I want us to go to the developing the model for our neural network. So another thing that I also like to show us here is partitioning the data, because we are going to need to partition the data. So in order to partition the data, I'm going to remove the correlation matrix and put split operator. So we use split data operator to partition the data. If I've lost you, like I said, don't be discouraged. The video is going to be available. You can easily watch it and redo it for yourself. So the split data operator is what we have here. So I can bring out the split data operator and put it. And just to be sure that we have the right connection, so I'm going to connect the data to it, and I'm going to run it like that. So now for the split data, if I click on it, remember split is used for partition. So if we want to partition our data into two, for this example now, the data is not much, it's just 24. So we can partition it into 60/40. So if I click on this, for example, and I click on this, it will ask me for the percentages that I want. So I want one to be 60%, so I can put 0.6, and then I have another one 0.4, so that makes 100%. So 60%, 40%. If I want to put it into 3, I can say 0.6, 0.4, 0. Okay, if it's 3, that means I need to say 0.6, 0.3, and 0.1, so that everything will add up to 100. So, and that will be okay. So I have two partitions, 60% and 40%, and that's, click on OK. So I'm just trying to move along so that we can gain speed. Like I said, you can easily practice this later. So let's just see what is going on, and let me run through to the end. So for the partitioning, I've put my split data. If I run this now, for example, and I see the output, I'll see that instead of having 24, it has splitted the data into 2. So we can see this first one that it has given me, this is the 60% partition. You can see we have just 14 there now. So the remaining 10 is in the 40%, which is the validation data set. So this is the 60% that we have. That's what it has displayed. So if I want to see the other ones, I can easily, go and look at it. So now I have the 60% being displayed to me right here. So the next thing I want to do is that I want to go to the visualization and actually see what is going on with this training data. So this is data that I'm going to use to train. That's the 60%. So let's do, for this 60%, let's do a scatter plot. Okay, great. So, and we see that income and lot size, and it has been color coded with the target variable. So right now, you can see that this is the same as that picture that I was using to explain to you the other time. Let's assume that there is a new owner that we don't know, owner that we don't know whether it's going to be an owner or it's going to be a non-owner. Okay, so let's assume that his income is 60 and the lot size is 20. So it will be exactly at this point. So we are looking at the neighbors being this, this, and this. Okay, so that's just by way of visualization. So we can now, since he has 3 most closest neighbor, because it's going to be here, where my mouse is, that's where it's going to be. So it's going to have a neighbor 18.4 and then 20.8 and so on and so forth. So we have 2 owners and 1 non-owner. So if this algorithm is going to predict for this particular new owner where my mouse is right now, it's going to be predicting that it's going to be an owner because we have 2 owners beside it and 1 non-owner. So that's how the KNN algorithm works. Okay, quickly, we are going to be going to the developing the model. So now I'm going back to my design. Okay, so now I'm in my design environment and I want to follow through. So I'm going to delete this. It's okay. We are going to, if we need it, we'll bring it back up. So I'm going to follow through designing the model, the KNN model now in RapidMiner. Like we said, I'm going to follow all those steps that we said we should follow. So it's like I'm repeating some of the things that we have talked about before. So the first thing is that this is our data. We have brought it in. The next thing is that we need to normalize. Normalize. So I'm looking for the normalization operator. Normalize. Okay, so this is the normalization operator. I bring it here. So I connect it. So I connect it. So the next thing is that I read in my data here. I want to normalize the data because it's a supervised learning model that I want to develop. Okay, the next thing that I want to do is I want to bring in an operator that will set the role. Okay, set the role of the attributes. Set role. Okay, so I've typed it and set role has come. I bring it here. The next thing that I want to do is that after I've normalized my data, I've set the target variable. The next thing that I want to do now is that I want to split the data. That's the partitioning. Remember, I'm just following those steps that I told you earlier. So I'm going to partition the data. Partition. That's split data. So split data. The next thing now is that after we have splitted the data, I'm still going to explain how to set the parameters of all these attributes. The next thing is to bring in our KNN model or algorithm. So you can see how I'm bringing out the KNN algorithm. I know most of us might not be doing the practical as I'm doing it. You will do it later, or else we will be wasting a lot of airtime, you know, for asking for, have you done it, have you not done it? So you can do it later or make the video available. So the next thing now is to set, that's to bring in the model. Now, if we are finished developing our model, we need to apply the model. Apply model. Okay, so the apply model is right there. Then the next thing that we need is to evaluate this model. Remember, that's part of the steps that I said earlier, the performance. We want to check the confusion metrics for the model. So we bring our performance. Remember that we can predict for categorical or numerical outcome, but in this situation, we are predicting for categorical outcome. So we are interested in bringing in the performance operator for classification. So that's what I'm bringing in there right now. So we have that. So all the operators we need is done. The next thing is to link them together and set the parameters. All right. So now, let's link them together. So we have our data right here. We want to normalize the data. So if I click on this normalization, for example, if it's all the attributes that I want to normalize, I have the opportunity of setting that here, and it comes by default. But if it's just some of the attributes, then I can click a subset, just like I did earlier, and then select those attributes. But we have just two, because the third one is the target variable. So we don't need to, that one is not even appearing. So I'm just going to leave it as all. All right. So the next thing is to set the role. Now we have linked these two together. If I click on this and I come to this point, that's the parameters to set the role. I want to set, first of all, I need to tell us the attribute's name. So by default, all the attributes that I have, that's listed it for me. So I'm going to set this ownership as the target variable. So I've selected ownership here, and I said it should be the label. Great. So the next thing now is that we now want to split the data to 60-40, just like we did earlier. So I'm just repeating it. So the next thing is to split the data. So I'm going to tell this to come right here to split the data. So the output of this particular operator comes to this splitting. So by clicking on this now, I can set the parameter If I click on split data, I can come to this parameter and edit it. There is an automatic for you, but I don't want automatic. I want to tell it the ratio. So just like we did earlier, 0.6 and add another entry, 0.4. So I've said you should split it to 60% and 40%. Okay. So the next thing is that I now want to, this data that I've splitted, remember, it's now in partitions. So I want to take the 60% and train it. That's what I'm doing by this arrow that I'm having here. You will notice that suddenly this has become 2 because I partitioned the data into 2. So the next thing that we have here is the 60% has come for the training. So that means that what is left in this place that my mouse is the remaining 40%, which we are going to use for the validation. So I can do that. All right. So now what's going to be here in these points now? Remember, this is the 60% that I trained. As I'm talking, you can follow the direction of my mouse. This is the 60% that I trained using this KNN algorithm. Now, I can now use the model that I got by training it. I can apply it. That's why I'm using the apply model operator. I can apply it on the remaining 40%. You can see this is the 40% that is coming to this apply model. The model that was gotten from the 60% that I trained is going to be applied on this validation data set. And then we are now going to check the accuracy. So I'm going to move this to check the accuracy. So assuming that the model that we got from our KNN, you can see model is here. We are applying it on the remaining 40%. Please check the accuracy for us using this accuracy performance operator. So if I click on this now, there are so many options, but we're just checking accuracy. That's why this is ticked. And we need to know that accuracy. So that's why I'm going to say, please, the results, show me the accuracy, and also show me the data, the validation data that gave me that accuracy. So I have two outputs here. So our model is ready. We are ready to run it. Hopefully there will not be any error. We can be able to see our model and we can be able to see the accuracy. So if I click on run right now, so everything looks good. This is the data that we used. That's the training, the validation data. Remember, what happens for validation is that we already have it predicted for in our historical data. So what we want to do is that we want to let our model, let it predict for the new, let it predict the category for the validation data set. So when it predicts the category now, we can now compare with the historical category that, does it tally? So if it tallies, oh great, that means our model predicted correctly. But how can we know how many the model predicted correctly, how many did not predict correctly? That is what is going to be happening in our confusion matrix. So let's check the confusion matrix by clicking on this. Okay, so remember the diagonal that I told you about. So out of the, how many data all do we have in our validation data set? That's 4 plus 1 plus 3 plus 1. So that's about 10. So out of the 10 transactions that we have in our validation data set, we have, this was correctly predicted positive, then this was correctly predicted negative. So we have 4 plus 3. So if you look at 4 plus 3 over everything, this 2 and 1 was wrong prediction. So if we look at 4 plus 3 over 10, we have 70%. So that means our model has an accuracy of 70%. So basically, that is how our model is being developed, and that is how it's being evaluated. Now we have not gotten to where we are going. Where we are actually going is that, assuming that we are okay with this accuracy now, we can now bring in new set of data that we don't know whether they are going to purchase lawnmower or not. So we don't have that ownership classification, whether owner or no owner. We don't have it. So we now need to predict for it. Okay. So I'm just going to keep going. If you notice, I've not asked how we are doing. I know we will do very well after we have practiced using the video, but let me run through the steps so that this will be a complete training. And we still have about 50 minutes. So now the next thing that we want to do now is that we want to be able to, this is our model that we ran and it gave us those results. So this is a typical, from beginning to the end, this is how you develop a KNN model on a training data set, split it, and then predict on the validation data set. So the next thing that we want to do now is that we want to predict for new record. If you remember where we were actually going when I started this introduction, was that when we are finished predicting, developing the model, we need to have a new data set that we don't know the classification. Now we now want to predict what the classification will be. So that is the next step that we want to go through now. So I'm just going to stop this briefly and okay, let me just continue. There's no need to stop it. So I can save this process and create a new process. So I can save this file, save process. I'm going to save it in the repository I created earlier, which is online KNN, and I'm going to save it under process this time around, not data. So I'm going to save it there. So I'm going to call it KNN model. Okay. All right. So now the next thing that I want to do now is I want to close this. I want to bring in a new process. So if you didn't catch it the first time, you have another opportunity to catch it again the second time. So I'm going to be doing what we did for developing the model again. It's just that I'm going to do it using another approach so that we can have a rich, perspective to how to do this thing in rapid manner. And when I now do it using a slightly different approach now, I'm now going to introduce predicting for new record into that approach. So by the time we are done, we will be able to predict for new record and, get the subset that we are looking for. Now, this is a new process that I've created. Like I said, there are various ways of bringing in your data. So the first time we brought in our data from this repository. Now I'm going to bring in my data from Excel, read Excel operator. Okay. So now this is the read Excel operator. I'm bringing it because it's an Excel file that I'm planning to load. So you can see this is another way of bringing in our data. So now I have my read Excel. The next thing is to set row. If you notice, we are repeating some things, so we'll be able to get it better. Set row. Okay. Then the next thing is to normalize. So I kind of changed it this time around. Is allowed. So normalize. Let's bring out our normalize operator. Okay. So we have our normalize operator. Then the next thing is to wrap our KNN model inside a validation model. So this, as I said, I'm using a different approach. So it's good for us to know the various approaches, because this particular second one is the one that can help us to actually predict for new transaction, and that is where we are going. So now we have validation. We are looking for the validation operator. Okay, so I'm going to pick split validation. Assuming I was using cross validation, and that is an explanation for another training, I will probably bring out cross validation. But we'll tell us when we use cross validation later. But for now, since we are splitting 60%, 40%, so it's the validation operator that we bring out. So now we have the validation. I'm going to have to tie all this together. So this links to this, this links to this, this links to this. Now, the outputs of this validation should give us our model, and it should also give us whatever data that we are interested in. Sorry. Okay, so we have this and we have this. I will explain this just in a minute. So now for this approach that I'm using now, if you can see that up until now, we have just set the role, we normalize our data, and then we put it inside this validation operator. We have not talked about the KNN algorithm. So I'm going to bring in the KNN algorithm. I'm going to put it inside this validation operator. Okay. So now, when we have this now, this is where we get to set our training and our testing data, just like the other ones that we had. So you notice that there is no split operator like we had earlier. So we now have here, we want to apply our KNN to our training. So I can bring in my KNN model. I'm still going to explain a general overview before we end everything. So I have my KNN here. The next thing I want to bring out is the apply model. You can see the other way that we are using to use we are using to apply our model now. So you have two ways of doing it, which is great. So you want whatever is comfortable for you. So I'm bringing in my apply model here, and then the performance that we used. Performance. So it's still classification performance. Okay, great. So the next thing now is to just link all this together. Okay. Then we link this, and then we link this. So what does all this mean? I will just do a quick explanation. What we are simply doing is that, remember, all this that we have here is inside this validation. So if you double click on this validation, that's how you get to this point. So what we are simply saying is that when we read in our data, we set the role that we say, let me just begin and start explaining. So we read in our Excel file. Remember, this is another way of bringing in the data that we have not brought in before. So we bring in the data. The data is right there on my desktop, just like I brought it out earlier. So I'm going to bring in the riding more data again. Okay. So it's still the same process as we did earlier. So now the data is inside this Excel file. The next thing is that, so I'm doing these things, some of them I'm doing it over again, what I did before, but in another way. So the set the role, okay, you click on it, and then pick the attributes, that is the target variable, and you set it as the label. Then you normalize, we are using all the data, so there's no need to adjust anything there. Then in this our validation, that's where I put my KNN model. I wrapped it inside. So the idea is, please pick KNN model, split the data 60-40, and then apply to 60, validate with 40. That's what this is doing. But I'm going to go back to the process and make sure that I have my percentage correctly. So the split ratio here, okay, this will split it into 2. So the split ratio should, take note, you should change that to 0.6 if you want it to be like what we did earlier. But if not, you can leave it at 0.7. So I change it to the 0.6, 60-40. That's the validation, setting the parameters for validation operator. Now, if I double click on this, I have my KNN. I'm applying it on the 60%, and then I want to check the performance too. And I want it to give me the output. So the output of this will be fed back into the process here, and then it can be displayed for you. So the next thing that we want to have here, I want to correct this. Okay. So the next thing that we want to have is that, remember I said the reason why I want to show you this second approach is so that we can see how we can predict the new data. So how do we predict the new data? We can do that coming over to this interface here, right here, and now let's load in the new data that we want to predict, and we need a read Excel file to do that too. So read Excel, I'm bringing in the second read Excel file. So just be patient, and then you practice your own later. So see this read Excel file. The first one helped me to bring in the historical data, which I splitted and so on and so forth. Now this second one is helping me to bring in the data that I want to predict for. So if you check the data that we sent to you, there's a second one that says new riding mower. That is the one that I'm going to look for now and put inside this one, because if you check that data, maybe I should just show you. So I'm going to stop and come back to this rapid miner. Okay, I think it's best I show you in the rapid miner so that we won't waste too much time. Okay, let me just do a quick housekeep. How many of us can see the rapid miner screen? I'm back in rapid miner. Please send me a chat. Send me a chat, please. I'm back in the rapid miner. Can we see the rapid miner screen? Yes, I can. Okay, thank you. So I'm back in the rapid miner. When I load in the data, I will explain what I wanted to explain to you in the Excel file. So now we want to predict. Okay. So now we want to predict for new data. We said this read Excel will help us to load in that new data. So if I click on it, let me now load it in now. Okay, so if I click on this now, I want to bring in the new data, the transaction that doesn't have label that I want to predict for. So I go to my desktop where it is. I look for the data. So this is the folder that we sent to you. So this is the data that we want to predict, new records. So if I click on it, I can click on next. Okay, so if you look at this now, this is not part of the training data or validation data set. This is a new data that I want to predict. So let's assume that these are our new customers that we want to determine the subset or that we want to predict for, and then determine the subset that has the highest probability of doing business with us or being an homeowner or whatever application scenario that you are looking at. So now the next thing is to load in this data. You can see that's only 2 columns. It doesn't have the ownership, it doesn't have the label. So finish. So I brought in the data using this, going to the desktop, I'm just repeating it, going to the desktop, picking the topic, picking the folder, new records, next, next, and then finish. Now, the next thing now is to have the, it is more tidy, because the idea is whatever we get from this validation, the model that this gives us after we have validated it and we feel that is okay, the percentage accuracy is okay, now we want to apply it on this new data, let it predict for us. How do we do that? What we are simply doing is that it's more tidy to use this operator to group all the models together. Group operator, group models, sorry. So group model operator, I'm bringing it. What's this guy supposed to do? The idea is that all the things that we did on this data, this read Excel data, this first one, we want to also do it on this new read Excel data, so that if it's normalized, we want to normalize it so that they will be on the same terrain. So now, in order to now be, for this one, instead of me to say, for this read, second read Excel, instead of me to now say set role, normalize, as in copy this, and put it here, I can just group everything that happened, okay, before this validation and put it inside this group model, then apply it on this data, and then it means the same thing. So that's why I can bring this now to this group model. So what this means is that 1, 2, they have been grouped together, they are inside this group model. The next thing now is that I now want to bring whatever, so I'm going to cut this. So whatever model that we got, remember what's inside this validation. Let me click it again for you to see. Okay, we have our KNN that is being applied on the training data. And after that, we check the performance. Okay, it's good, it's 70%. Now we are good to go. Let's now apply it on the testing data, which is 40%. And then we have been able to get that accuracy. So now, going back, whatever we have here as our model that evolved, we want to also put it inside this place. So inside this group model, what it simply means is that what we have inside this group model is that we have set role, normalize, and the model that we got from this particular validation exercise, the training and validation. So all of them, we have put it inside this place. So we are now going to be applying it on this new data to predict for us. All right. In order to do that, we need apply model. So apply model. So I bring the apply model here. All right. Now I have the apply model. So I'm going to join this to this point, and I'm going to join this to this point. Great. So the next thing now is that if it has applied the model that we got that has been evaluated on the new data set, it's very good for us to save it and see it. So I want to bring in a write Excel operator so that it will go and save it in an Excel file. But take note, that Excel file, you should have created it before, then empty it, nothing is inside it, so that when it predicts for this new data, it will just go and store it inside the Excel file. Okay, so let me bring in write Excel. Write Excel. All right, so we have this write Excel. This is where I'm going to be writing my results. So when it has applied all the models on this new data that I want to predict, now write the results inside this Excel file. And it's also good, just in case you want to see the model, we can say, let the model be outputted too. So let me just drag this so that we can see what's going on. But if you don't want to see the model, you can easily forget about this. But let's just see what the model looks like. So it might even have to ask you which model actually, but let's just have it. So now, but the most important link here is from this apply model to the right Excel, because that's what is going to tell us what has been predicted, and it will save it inside the Excel file. So now we are good to go. If everything goes well, by the time we run this, we shouldn't have any error. But let's just go through it one by one and check that all our parameters are in order. So I have my read Excel. I brought in my Excel sheet. I'm going to do it again, just in case. Desktop. The data, that the historical data, that's riding MOAs, next. Okay, and then we have next. Finish. Set the role. Make sure that, click on set role, go to parameters, everything is in order. Ownership is the label. The next thing is to normalize. Click on normalization, all the attributes we want to normalize, and is using Z transformation. All right. The next thing is our validation. I'm going to click on that and see what's going on there to be sure that it's in order. So the KNN, I click on it. Remember that for this KNN, I think I forgot to say it when we were trying the first time. For this KNN, the number of K, okay, can vary. So as a scientist, you want to try several numbers of K and see the one that gives you the best accuracy. So when we did it the other time, we just picked 5. That's the default. So, and that's what gave us that accuracy. You might be surprised that you can pick K of 7. The accuracy might be better. So we still go with this default K. And then apply model, we don't have anything to set there. Performance is accuracy, we don't have anything to set there. So I'm going back to the process. So that means that this is looking tidy, this is done, this is okay. So the next thing now is group model. We don't have anything to set there too. Once what you are loading into it is correct, you are good to go. So what we are loading into is we are loading it set role and normalize. We are loading it into this group model, and then validation outputs. We are loading, that's the model that we get from our training data. We are loading it into this group model too. So the next thing I want to check too is this. Have I brought in the data that I want to predict for? No. So I need to do that. So I click on this. It's on the desktop. I pick it. So new records. That's what I want to create. I'm not too sure whether I brought it in, but if I brought it in, well, that means I'm bringing it again. It's not a crime. Then apply model. We don't have anything to set there. Then write. We want it to write in an Excel file. We need to tell it which Excel file it should write to. So if I click on this and I click on this, I might be able to pick the Excel file that it should write to. So my Excel file, so this outMOA is the Excel file that I need to create before and make sure that it's empty, so that when it predicts, the results will go there. So I'm selecting it and I'm clicking on open. So it appears that we are ready to go. So all things being equal, we shouldn't have any form of error. So now we are ready to run our model, let it train, evaluate the results, then apply it on a new data set. Remember, the reason why we did that first one is without applying it on a new data set to see the evaluation, so that we can be able to tweak whatever we needed to tweak before we come and finally use it to predict on a new data set. So in this stage now, we are assuming that we have been able to get the accuracy that we need based on those partitions, based on the attributes that was selected, so we can apply it. That is the assumption here now. So let's run this and let's see what it gives us. So far we don't have any error, and we actually have a successful outing. But if you look at this now, you see that we are not having any result here. That's because the model is not being displayed. So it's just telling us to select the first output that we have in our design. I'm going to come back here. In our design, we said this result, I told you that this is the output. So we are expecting two outputs. We are expecting the one of the result, that's the application, that's the model, the group models that we applied. We are expecting it as an output. And we're also expecting the output in our Excel sheet. So I'm going to go and show you that output in the Excel sheet. But for the first one, which is the output of the model, if I go back to the result, it's asking me that you select which model. Remember, we brought our normalization was part of the models that we grouped together. So this is the normalization model that it showed us. Then the second model is our KNN model. So there's really not much to tell. The model contains 24 examples, 2 dimensions. But where we are actually going is that we want to see what it predicted for those new data. But we said it should put it in an Excel file. So it's that Excel file now that I have to go and open. That one is not, if you wanted it to show in RapidMiner, would have put maybe the output of this Excel file, something like this, to come here, and that would have showed us whatever we had inside the RapidMiner. So now let's now go to the Excel sheet and go and see what it has predicted. Okay, so I'm going to go to the Excel sheet. So I'm going to go to the desktop where I put the Excel sheet. So output MOAs. Okay. So this is the Excel sheet that I created and I selected earlier. My Excel sheet is still loading. This is not the one. Just minimize this. So the output MOA is still loading. That's where the result is. I'm going to wait for it to load so that I can explain it. And then we'll probably be getting ready to round up. So it's taking some time. I'm going to have to wait for it. So basically, what has happened is that we have been able to predict for a new record that we had. And now that we have now predicted, so that new record is supposed to be the prospective customers that we have predicted for. So if we now have those predictions now, I want the output to come out so that I will show you the propensity in the output. So is the propensity now in that Excel sheet that we can now rank and look for the customers that have, or the customers that have the highest probability. So those are the ones that we are going to target. So for example, if this was not for a lawnmower, buying lawnmower or not, if these were customers of a specific business or not, and we have been able to predict that they are going to come and do business with us, then whatever that prediction is, we can now rank them to know who has 99% probability of doing business with us. Those are the ones that we are interested in. Those are the subset that we set out to find out at the onset. Okay, this is taking some time. Okay, so it has come up. I'm going to share my screen so that we can see it. Yeah. So this is the Excel sheet now. So this is the Excel sheet that we said you should store the result. So if you have done your own well too, this is what you should be having. So now let's interpret what this is now. Okay. So looking at this now, we will see that this is what we loaded when we're loading the new data into our rapid miner. So we loaded income, lot size. Those are the two things. So we said it should predict for us whether it's going to be an owner or it's going to be a non-owner. So what happened is that we can see that we call something propensity for KNN algorithm. Okay, so we need this to be able to, we need to understand this explanation so that we can be able to conclude and make inferences from our results. The idea now is that for KNN, it uses what we call propensities or probabilities to classify whether you're going to be in this class or not in this class. And the cutoff, the default cutoff for that probability between 0 and 1, the default is 0.5, which is 50%. So if it's going to classify you as an owner, which is the positive class, for example, it will pick if your propensity, that's the probability that it calculated for you. If it's 0.5 upwards, it will classify you as owner. If it's below 0.5, that will be non-owner. So looking at these outputs, before I continue talking, let me just take a poll. I hope you can see the Excel sheet because that's what I'm using to explain. Please, if you can see the Excel sheet, give me a yes, please. Give me a yes. The Excel sheet. Give me a yes if you can see the, okay, thank God, thank God. So I can continue. So now let's look at this Excel sheet now. So looking at this Excel, this is what the results of our rapid miner gave us. Now, as I was saying, I want to predict for number 2, number 3, number 4, number 5, number 6, number 7, number 8. I didn't have the data I loaded. I did not have all this there, but it has given me this answer. So what does this answer mean? So what it simply means is that for these 6 people that I'm predicting for, or 1, 2, 3, 4, 5, 6, 7, okay, for these 7 new people that I'm predicting for, the probability that there will be, this first one, for example, that it will be an owner is 0.2, that's 20%. The probability that is going to be a non-owner is 0.8. So because of that, it has predicted that it's going to be a non-owner. How? It used 0.5 as the cutoff. So now every transaction that has 0.5 and above will be predicted as non-owner, lower will be predicted as owner. So that's just how we are. So depending on whichever you set, as your the one that it should predict for. So now the idea now is that for this one now, this number 3 now, you can see that the confidence of owner, that's probability of being an owner, is 0.6. Being a non-owner is 0.4. So it has classified it as an owner using that probability. So now what we are actually interested in to use for our ranking is this the probability that he used to make his conclusion. So for example now, if I create a new column here, for example, so let's say that this new column it has predicted as non-owner, so that is used 0.8 for this one. So this is 0.6. Okay, that is actually what it used because that was what was higher. Then this is this one is owner, that's 0.6. 0.6. Then we have, this is 1.0. So you categorized it as owner. So that's 1.0. Then this is 1.02, 1.0. Okay. So this is 0.6. So that is what he used to make his decision. The one that is greater than 0.5, and this is 0.8. So that means that what I have in this new column, for example, is the probability. Propensity or probability, we can call it probability or propensity for making this decision. So if I want to know which one, for example, I'm interested in owner, I'm interested in those people that will be ready to be a owner of a lawnmower. So these are the ones that I'm interested in. Okay, these are the ones that I'm looking for. I'm not interested in non-owner because already it's predicting that they are not going to do business with me. So I don't have any business with them too. So now these owners, they are the ones that I will expunge out of this list now. So if I can expunge these ones out of this list, I can now rank them based on this, their probability. So you can see that what we have done, we have gone beyond prediction. We now want to make recommendations, for example, to management, that these are the ones that you should spend your money on. They are the ones that has probability of doing business with you. So if I sort this now, this particular 1, 2, 3, 4, 5 of them that are owner, if I sort them in descending order, I will be able to see which one has the highest probability. And it's looking like it's number 5 and 6 that have probability of 100%, that's 1.0, of if I target them, definitely they will do business with me. So that is how to solve the problem that we set out to solve. So going back to my slide now, just to conclude so that we can round up. So I'm back on my slide. So most of these things that is here, we've already talked about them, but I want to go straight to the slide that we make our conclusion. Okay, so this is it. Like we said, when we started, this is going to take me through the journey to get to that last point, but I'll go through the journey. So I want to conclude. Okay, so which subset of prospective customers do you target? Now we built an algorithm, a model that helps us to predict for new customers after we were sure that the accuracy was satisfiable. Now, after predicting for those new customers, we looked at those ones that they would actually, do business. It will predict for success, that they're going to do business and all that. We have expunged them out of that Excel sheet. We have ranked them in descending order. So we know the one that has the highest probability. So those are the ones that we are going to target. So I'm going to go back to where we started from so that we'll be able to round up from there. Remember, when we set out, our goal was that if we have a training, an historical data that we were able to train and validate using the validation data, and we're able to be satisfied that our model is okay, the accuracy is okay, we predicted on new data sets. From there, we were able to get whether you are going to do business or not. Those that are going to do business, we now ranked them in descending order. And the ones on top, which has the highest probability, They are the ones that are here now. So they are that subset that we are interested in, that we set out to target. So that's where I'm going to be concluding this course. Remember, I said it's a lot to take in, particularly if you are just coming up or getting on board of data science, but it's good that you start from somewhere. For example, whatever you learned today can never be new to you again, and you can easily build on it. But my candid advice to you is that you should not assume that you know everything by just listening to courses. You need to sit down, run the programs, run the application, run whatever you need to run in form of a practical to be able to get the full understanding of what exactly you need. I'm just running through all the slides. And then by that way, you are able to, you'll be familiar with it, you'll be used to whatever you need to do. So there's no time to be doing the second part that I planned, but it's okay. We have the data already. So this exercise, so somebody was asking me from the chat that I should use another example, and I said, okay, let's start with the smallest example, because not everybody that can move at the same speed. But now you have an idea of how to do this thing. This is another problem scenario for predicting, you know, whether a customer will want to take a loan or not take a loan. So if we have historical data of those that have taken loans in the past, you can easily train it based on the steps that we did for the simple one that we took as an example. Train it, get a model, use it to predict. And if you see the data that we sent, we also sent both the traders. This data has been sent to you to use for this problem, has been sent to you. So we sent the data. We also sent the new one that doesn't have the label so that you can also predict. So all you have to do in order to practice and master whatever we have taught today is to just pick those data, get your RapidMiner, and follow the steps, the video, which I will give you access to. And then you can see that you have easily been able to solve this problem. So the data is there. It has more attributes than the one we used, but it's still the same procedure. So then this data description, I'm not going to go through this. So I have some solution steps that you can follow that can guide you. They are basically the same steps that we used to solve the other one, just to adjust it, customize it for this particular problem. So please, there is no being a data scientist without practice. Try this example on your own. And like I said when I was introducing the course, that we have an interaction platform 3 to 4 every Wednesday. So provided you are trying this now and you didn't get it, you have some issues, you can, the group will be created before that Wednesday. So you can easily post your problem there, and then you can get solutions in real time before the next training, or before we can keep posting. Even if we have another training and you are still interested, you have a challenge with this one, you can keep posting and we will get back to you. So these are some of the guides to solving the problem. These are some of the guides. These are the attributes in that new data set that you want to practice. So these are some of the ways to solve it. So I put some of these solutions there so that you can be able to, it will be easy for you. Finally, the references. Please, these are a rich set of resources for you to check out to help you to learn better and faster. And that's where we are going to be stopping.